So this is a video on implicit differentiation, which is really just, you're just taking a derivative, but it's when we take a derivative of something, of an equation that's in implicit form. So the difference between an equation that's implicit form just means that that you have not isolated the dependent variable. So this equation right now is in explicit form because the dependent variable is by itself. Y is the dependent variable, x is the independent variable, and you can see that y is by itself in this equation. An implicit equation, example of implicit equation would be like x squared plus 3xy minus y squared is equal to 7 or something like that. So that would be an implicit equation because the dependent variable and the independent variable are intermixed. And it actually, it'd be a hard time to get the y variable by itself. So implicit differentiation is just basically the idea that because I can't get y by itself, because it'd be hard to get y by itself, I'd rather just take the derivative without getting y by itself. So we're going to go back here and look at this a minute. So the way we would normally, if I asked you to find the derivative of this, I would say what is dy dx would be one way to ask that, right? Well, you can see that I can find in this equation, and I can find dy dx by just taking the derivative of both sides with respect to x. Because if I take the derivative of this side with respect to x and this side with respect to x, of course we get dy dx on this side. And over here, I'm going to get the derivative of 3x squared with respect to x, which of course would be 6x, and the derivative of 5, which would be 0. So we find out that dy dx is 6x. Okay, so we can do that same idea over here if we just take the derivative of both sides of the equation. So I'm taking the derivative of both sides of the equation with respect to x. So if I take the derivative of x squared, that would be 2x. And since I'm taking it with respect to x, the derivative or the chain rule kicks out just a 1 because the derivative of x is 1. The derivative of x with respect to x is 1. I get to the second one. Now if I'm taking the derivative of this with respect to x, notice that this is the product rule because it's 3x times y. So I'd have to take the derivative first. Now the derivative of 3x would just be 3 dx dx, which is just 1, times y, plus 3x times the derivative of y. Now the derivative of y with respect to x is not 1. So we'd have to write dy dx. And then we take the derivative of y squared. Of course, that would be 2y times the derivative of y because of the chain rule. And the derivative of y, once again, is not 1, so that'd be dy dx. And then finally, the derivative of 7 with respect to x is 0. So you can see we've taken a derivative, and we've got some dy dx's showing up in the equation, but they're not, but there's a couple of them. They're mixed together. And again, my goal was to find out what the derivative of y is, or dy dx. So what I'm going to do is subtract 2x and 3y from both sides. So now I have 3x dy dx minus 2y dy dx is equal to negative 2x minus 3y. And then, because I'm trying to solve for dy dx, I'm going to factor out the dy dx. And that would leave me with 3x minus 2y is equal to negative 2x minus 3y. And that's divide both sides by the 3x minus 2y. And finally, I get dy dx is equal to negative 2x minus 3y over 3x minus 2y. And that would be my dy dx. And now, just like we've been studying, this is just dy dx. It's the derivative of y with respect to x. It's the slope, because it's changing y over change x. It's the slope of this graph up here at a certain point. I mean, this is a formula for finding the slope at any point. So if I pick some point that's on this graph, I could plug in both. And notice the difference here is my description of the slope involves an x and a y. So if I wanted to know the slope at this point, I'd have to know the x coordinate and the y coordinate. I just plug them both in and it would give me the slope. So same exact thing. We're still just taking a derivative. The only difference is most every one we've taken derivative so far was in explicit form, but now we're going to take derivatives of equations in implicit form.